This is a similar but different question from Pure Book 1, exercise 6D, question 10. So we've been asked to find where the line with this equation intersects the circle with this equation, such that it's crossing at two distinct points, so it's not just touching the circle. And what we're looking at is what values of k will allow these to intersect. So I'm just going to look at it in GeoGebra first to get a feeling for the problem. So here we have a slider I've made, so it allows me to move my line around, and of course I've drawn the circle. So what we're looking at is for the places where the line will intersect the circle at 2 points, and what values of k that will be. So as we can see, k needs to be about 7 or so, less than 7, going down, still intersecting twice, going down. Okay, okay, so about 1, 0.8, 0.7 maybe will be where it then goes off the circle again. So we think it's going to be around those two values, about 0.7 up to about 7. So the first thing to do is to simply write the equation of the circle down, and then we'll substitute in y equals kx to find where they intersect. So I collect terms so that it's now a quadratic, and what I'm looking for is this to have two solutions. I know that to find two solutions to a quadratic, the discriminant must be more than 0. So I tell the examiner that I know that. I write down the discriminant for this particular quadratic. I then collect terms, and then in this case I look and see what the question is asking me, and I realize that I need to multiply through by -1 to get the form that they want. But in this case you must be careful when you're doing this to do that reversing. If you're not quite sure why, do think about it. If I said that 3 is more than 0, then I multiply through by -1, then -3 will be less than 0. So it does actually make sense. The other thing to note is that I'm using a strict inequality because that gives 2 points of intersection. I've put this into GeoGebra, just have a look at how it actually is working, and we can see that the solutions to that are just below 1 up to just above 7. Rather than simplifying and trying to solve, I've just decided to use the quadratic formula because it probably won't come out, and certainly here we can see it didn't come out particularly nicely. So here we've got the roots, the 0.7-ish one and the 7-ish one. And then I write it down properly using, again, strict inequality symbols. So the key points are you need to be able to combine two separate equations to find where lines cross. You need to be able to collect terms in an expression that you formed where you have unknowns in the coefficients. You need to understand how to use discriminants. You need to be able to solve quadratic inequalities and then write them down correctly. Notice that I gave 4 significant figures for those 2 figures. I just wanted to make sure if I did make an error that I should still get the mark